Okay, so what we're going to show you guys today is how we go through the general workflow. I'm just going to select a new job. I'm going to select my material and my fixture that I'm going to use. For this case, we're going to use a disc. Select the checkbox, and that's going to move us forward to the next step. So here we can see my STL files. I can pull up some previews, get some general nesting information like my height, as well as the height scaled since I chose zirconia. And that kind of gives us some information about how we're going to nest this part within the block. I'm going to select a couple of crowns here, and they're both full contour, so I can import those. While those are importing, it's detecting the margin line information and also the best insertion based on the machine's axis capabilities as well as the prep direction. And I'm going to go up a folder here. Since I've brought those in, I'm going to bring in a full contour bridge as well. We'll bring in this 6-unit bridge, or excuse me, 4-unit bridge that has multiple insertion directions. And we're going to select full contour bridge and hit the checkbox to move forward. So again, it's going to detect all the prep lines for us properly and bring that bridge in. Okay, now that I've got my bridge imported, I'm simply going to select from my materials that I have available to me. This one I need a 15.41 millimeter disc. So I'm going to try and use one of my partially used 16 millimeter discs. Okay, and we can see that 2 of them can fit, but one of the objects is not going to be able to fit in this job. It's possible that I could make it fit, but maybe for this case we'll just simply use a brand new 16 millimeter disc. Here I'm going to put in my scaling factor based off the information from the disc. Okay, and then any lot code information I have here, I'm going to put that in as well. And I did give it a stock or blank name. Usually what I would recommend is writing this on the side of the disk, so that way I can easily find it and correspond my digital files with my actually partially used material. And so from this point, I can simply either start the milling on the machine. If my machine supports that capability, I can stream to it, meaning after the first roughing toolpath is calculated, it's automatically going to start machining. Otherwise, I'm going to save my toolpath, and saving my toolpath will allow me to later execute that after the calculation is done. We're going to run a simulation after the calculation process, and we're going to get 2 more prompt windows here. The next prompt window is going to come up with a list of milling options, and we're going to be able to kind of choose the cutting characteristics for this particular job. At this point, since I do have anatomic, I'm going to do some anatomic milling on the occlusal with the 0.3. We won't do the internal prep refinement with the 0.6, but I would like the 0.6 to come in and do some interproximal milling on the interproximal areas here on this bridge to just give us a little bit better refinement there. And the very last window that we're going to get is what we call the tools table reminder, which is going to tell us what tools go in what slots and give us a life indicator of those tools as well. And then after we've selected our tools, or after we've confirmed our tools, the calculation process will now commence. After the calculation is complete, we'll have a residual material color map, which is going to show us the areas that are going to be partially left behind. So we'll wait till we get to that point, and we'll discuss that a little bit more. Okay, so now we're prompted to update our tool life parameters using the current toolpath. What that means is that we're basically faced with a choice here of, did we actually run this on the machine or not? If we didn't, if we plan on not running it, we're going to say no, so that way our tool life doesn't get adjusted. If we say yes, next time we go around, our tool life will be adjusted. Okay, so now our calculation is actually done. What we're going to notice here is that it shows us a color map of the residual material left behind. We also do have a notification of where that file is located, so that way we can go ahead and run that on the controller. So at this point, now I can rotate my parts, And based off of how I nested these parts in here and the selections I made during the machining selection, we can see that in some areas, due to poor pin placement, we can see that there's going to be excess material here left behind. And so the colors are indicated by these values over here. So in areas of green or light green, we're going to have 0.2 millimeters of material left behind. In areas of yellow, we're going to have up to 0.5 millimeter, and orange is going to be indicated by an 0.8 of a millimeter, and so on and so forth. Blue is anything over top of those values. So lastly, we're just going to go over to the simulation. If we want to see the kinematic simulation, we can. So when we click on the kinematic simulation, this is going to open up our classic simulation tool. And from this point, we're going to be able to essentially run through the job and see how it actually will mill out on the machine itself. Okay, now our simulation tool is properly loaded. What we're going to go ahead and do is just maximize this window. And I don't really need to see the toolpaths themselves, so I'm going to turn that off. And then I'm going to hit play to run this simulation. We're going to see we have an accurate representation of the tool and all the components, including the spindle as well as the tool holder in here. And from this point, I can also speed up or slow down the simulation, depending on what I'm wanting to do here. We can see a little progress bar here at the bottom of the screen. I can click and drag to skip ahead or to go back in the process. And when I do drag to go forward in the process, it has to do number crunching to be able to show me the difference in display of where we're at in the timeline versus where we were when we started the skipping procedure. And so I can hit play to kind of continue the simulation and just watch what the tool is going to do throughout its process. And if I want to skip all the way to the end, I can by simply just dragging this slider all the way to the end. And here we can see the final result of what's going to come off of the actual machine itself. So this is a good way to kind of check the toolpaths, if you will, and maybe even check to make sure that it's the quality of finish that you're looking for based off of what you selected in the strategy options. So for some reason, if I decided that, hey, you know, I actually want this this area on the lingual side of this cutback to come back and mill all that area out, when I was in my strategy selection, I would have needed to select the undercut milling option. So this is just a neat little tool to be able to visualize the end result and just kind of verify that the selections that you made for the milling process are going to be what was desired to be able to get the results from your CAD produced file. At this point, I can go ahead and close out of the simulation tool, and it'll take me straight back to MillBox. If I go to Tools and I click on Toolpaths, we can see here's the job name information. All the information related to the job is here in the bottom left-hand corner. And we can see our timestamp of 14/20/46. Here's now the NC file that's related to that job. So we can actually upload this to our machine controller, get it working on the machine. So that concludes our video of showing you guys how to go through the main workflow within MillBox. If you guys have any questions, be sure to leave those in the comment section down below. Thanks for watching.